Hi, my name is Harsha, and this is my lab for circuits. So the introduction. So the purpose was to observe how resistors, capacitors, and current, and like other aspects of circuits interact with each other. So the principles we use like the loop rule, the node rule, Ohm's law, edge conservation, capacitors, resistors in series, and parallel series. So the net potential difference will always be zero in a complete loop. The system was like an ammeter and a voltmeter. The surroundings was like the RC circuit, and the initial conditions was the circuit is closed and the combination of resistors and circuits. So experiment was like the initial prediction was like the change in V was going to be zero. The EM final plus the EM final minus I times the resistor one minus R times the resistor two would be zero, and then I would be like this entire equation right here. So, and that would be around 0.02 amps. The actual current was 0.02 amps, and the flipped ammeter was zero point zero 0.02 amps. The voltmeter read about 3 volts, and the I was around 0 amps. So this was kind of the graph that was there that we came up with in the experiment for the potential versus time. The experiment itself, these are the two pictures of the experiment itself. So the current reading goes up because less current goes through the 100 ohm resistor and instead goes into the ammeter, increasing its value. This is kind of like the chart. So the RC was 1 divided by the slope, so that's around 5.314, and the expected was around 6. Um, Now to the what if. So the question was, what if you were doing this lab simulate in simulation and used a simulated ammeter instead of a real ammeter? What is the difference about a real ammeter, and how would it have different? How would it have affected the circuits you hooked up to it? And if you did this lab with fake circuit components, see if you could determine how it would behave from the real ammeter you use. So a simulated ammeter acts as an ideal device with no internal resistance, unlike a real ammeter, which adds a slight resistance to the circuit, potentially affecting current flow and accuracy. Real ammeters also introduce practical measurement limits and slight real-time fluctuations, factors often absent in simulations, leading to subtle differences between simulated and actual circuit behavior. And the second what if was, what if you were simulating this lab and use a simulated battery to charge a simulated capacitor with no resistor in the circuit? How quickly would your ideal model predict the capacitor to reach full charge? And would this prediction happen in real life? So in an ideal simulation, a capacitor connected directly to a simulated battery without a resistor would be predicted to reach full charge instantly, as ideal components would allow an instantaneous current flow. However, in real life, the capacitor wouldn't charge instantly due to inherent resistance in wires and components, as well as the capacitor's own charging limits. Real circuits always have some resistance, in which creates a charging delay and prevents the theoretically instant charge seen in ideal simulations. Now, the sources of error were mainly related to the stopwatch error due to human delay in input, and incorrect procedure, and battery blowing up because like we weren't able to do it the first time. So this is my lab for circuits. Thank you.